Hello YouTube and welcome back to Shocked Up. I'm your host Andres and today we'll be reviewing stuff from our latest build, the Tesla Coil. Now hopefully by now you've successfully completed the build and have your own fully functioning Tesla Coil. Man, what am I talking about? You probably already finished it. I mean, you're so smart. But with great coil comes great responsibility. I mean, you can't show this baby off to your friends and family and then be dumbfounded if they ask you a question. Hey dude, look what I just made.
Cool, what is that?
I don't know. But look what it can do.
How does it work?
I don't know.
How do you not know?
Yeesh. So hopefully by the end of this video you'll know everything you need to know to astonish everyone with your brain. Let's get started. Okay, so now we're just going to start off with some brief history. Yeah, I know. Let's just get through this and then we can get to the more interesting stuff. Alright? Wait, I don't need glasses. So, how the hell am I supposed to read this? I'm not trying to bore these people to death. Hang on. Cut! Alright, cross this out. Okay, I think we're ready. So the Tesla Coil, invented in 1891 by Nikola Tesla himself, the same man who bestowed onto us three-phase AC power and the AC motor. Now what this is pretty much a high-frequency transformer that can produce very high voltages from very low currents. This was used in the first generation of transmitters and was also used in Tesla studies for X-rays, lighting, and wireless energy transmission. Okay, that's enough. So, how am I able to do all these neat tricks with this coil? First off, touching the arcs. Every time I show this to people, I always get asked, can I touch it? Well, yes, and I immediately show them how harmless it is. Now what gives? How come I'm not dying? I mean, I have said before that this gives off thousands of volts and mains voltage is only 120 volts. So what gives? How come when I touch this thing, I don't die? Well, this is something called the skin effect. So pretty much, this coil gives off high voltage at very high frequencies. Due to the high frequencies, the voltage actually stays on the outer layer of the skin and doesn't penetrate my body. Mains voltage, however, is at 60 Hz or 50 Hz, depending on where you live, and that will definitely penetrate the body and can potentially kill you. Now, if one of your friends stopped the video right there when I said it wasn't harmful and then went to go stick a fork in the outlet, just let him go. Let natural selection do its thing, okay? Just let it happen. I'm just kidding. Make sure... Sorry about all that. So the next trick is the light bulb trick. Now, as you can see, when I turn the coil on and I bring a light bulb that isn't connected to anything near the coil, it'll light up. Now what gives? How come this works? Well, pretty much the secondary coil of the Tesla coil is made of 400 turns of magnet wire, which acts as an inductor. An inductor stores energy in the form of a magnetic field, and when it discharges, in this case, it releases a lot of that energy in the form of electromagnetic waves. So when we do that thousands of times a second, it blasts this light bulb with a lot of high frequency, high energy waves, and it's enough to excite the electrons in the fluorescent bulb and light it up. Now, as a disclosure, this will only work for fluorescent bulbs and not incandescent. And as another disclosure, if you have your phone too close to the coil while it's on, it can interfere with its performance and its touchscreen, and you might wonder, what's up, why isn't my phone working, and might get a little scared. But don't worry, just turn the coil off, let it de-energize, and your phone will return to its full capabilities in around a second or two. Now looking at the circuit that we have here on the board, we have our basic components here, our 1 microfarad capacitor, our 50 ohm resistor, and our 1 kilo ohm trim potentiometer. But now here we have our Mosfet, and for those of you who don't know, a Mosfet acts like a switch that can turn on and off thousands of times a second. And that is a frequency that we can tune with the trim potentiometer, and we tune that to the circuit's harmonic frequency. Now over here we have our primary coil. Now this primary, when this Mosfet is off, isn't connected to ground, so no energy flows through it. Now when we apply a voltage at the gate of the Mosfet, current flows through the primary coil to ground, and then this section acts like a transformer. So using the turns ratio, we have 30 volts on the primary coil and 1 turn on the primary and 400 turns on the secondary. So that equates to around 12,000 volts on the secondary coil. Now that's some crazy stuff, but not entirely true. That's something to take with a grain of salt because this isn't a perfect transformer, but this does act like a step up. And this is enough to ionize the air around the tip of the secondary coil, and that's enough to create that spark that we see on the Tesla coil. Well, that's all the time we have for today. Please subscribe if you haven't and like the video. And follow us on Instagram at ShockedUp so you're the first to know when new content is released. You can also DM us on Instagram if you have any questions or suggestions for future builds. And we will see you next time.